Thank you. So good morning, everybody. I'm Chris Swan, CTO at Cohesive FT. I'll explain what we do along the way. First off, I'll give you the sort of too long didn't read version of what I'm going to talk about, and then that'll give you some markers about the bits that are coming up. So the Docker Zero bridge. Who in the room has sort of done enough prodding around Docker networking to have seen the Docker Zero bridge? Stick your hand up. About half. Okay, good. So the Docker Zero bridge is at the heart of what Docker does by default for networking, and there's some IP tables magic in there as well, so I'm going to explain that. And then I'm going to talk about container linking, so we've touched upon that a few times already. I'll go past those bits quickly, and also sort of reference compositing tools. So Anand's just talked about Fig. I'll kind of refresh on that. I'm going to spend most of my time looking at some of the more advanced options. So there's a whole bunch of other things you can do on a single host, but I think more interestingly, there's a whole bunch of new things coming along that let you do Docker networking across multiple hosts, and there's a bunch of advanced tools starting to come about that let you manipulate those networks. So some of you probably sat there wondering, who the heck is this Chris guy and why is he talking about Docker networking? There's probably at least half a dozen other people in the room that could also be talking to you about Docker networking. So last summer, a bunch of our customers who've been running cloud networks for some years were coming along to us and saying, your product's great, but we'd like this in it as well or that in it as well. And we kind of realized that we could do this as one-offs, but we couldn't do anything structural. Every one of those customers would want a different way of configuring their SSL termination or their reverse proxy or their load balancing. And so how could we give them that control? And the answer turned out to be, put Docker inside of our product, and that's exactly what we did. So this was what we released in April, and the journey of discovery along the way led me into learning just a little bit about how Docker does its networking so that we could make Docker networking play nicely with our networking. So let's start out with the basics. I'm going to take a regular host. So I don't care whether this is a VM or a cloud machine or just your laptop. It's probably going to have an Ethernet interface, and it's probably going to have an IP attached to it, and it might be something like 10.0.1.1. And let's install Docker onto that. So on the right-hand side of this, I've now got a container subsystem, and within the host, it's created a bridge. And the Docker install script's kind of clever enough to poke around your networking on the host and identify a place that it's not going to clash with things. But by default, the host end of that bridge will get an IP address like 172.17.42.1. Pretty much all of your Docker Zeros will have that IP address because most people, when they're using the private IP ranges, they use either the 192.168 class C or they're using the 10. Class A. And so people that do networky things tend to choose the class B ranges because there's less kind of interference going on there with things like home routers, etc. So as soon as we start a container, then you get a pair of interfaces are created and paired up and then attached to the Docker Zero bridge. So on the host side of it, you've got this VE thing, which will get a random number assigned to it, so something like 67AB. And inside of the container, the complementary pair to that is ETH0. So inside of your container, if you're running a shell, it'll look like it's just a regular machine with an Ethernet 0 interface. And if we start another container, we get another interface pair and so on. So you'll get another randomly numbered vETH inside the host. And inside of the container, you've got another ETH0. And the magic of network namespaces is taking care of that mapping taking place so that each of your containers thinks that it's got an ETH0. And inside of the host, you're not having all kinds of collisions. And there's a bit of IP tables magic goes along with this as well. So in terms of connecting to the outside world, what's going on here is your host is acting as a NAT router to the outside world. And if we have a look inside of the IP tables, we'll see this masquerading line here where we're basically saying everything that's on the Docker network is masqueraded. So that's the NAT. And then we're pretty much, I guess, all familiar with doing port mapping, but I thought it would be worth taking a look under the hood of that. So when I spin up, let's say, my node red container, and I'm saying -dp and doing a port mapping, then I can see that inside of my Docker PS. I've got a port mapping from the host's 1880 to the container's 1880. What that's actually doing is inside of IP tables, I've got a dynamic port mapping from the host's 1880 into the 1880 on the IP address assigned to that container. So linking, we've touched upon linking, I guess, 3 times already today. And so a quick refresh of from the Docker command line, I can give containers names, and then I can link to the names of those containers from other containers. And that's kind of the outside view of it, which we've touched upon a few times. I thought it's also worth looking at the inside view of that. So somewhere you've actually got to consume that environment variable. And as Jerome said, pretty much everything is going to be environmental variable sensitive. And so you can, with my Ruby code, for instance, I can just say env and pick up the environment variable that's going to be populated with that crucial detail for the linking. Mileage might vary. If you're trying to do this with Nginx, then Nginx is using static configuration files, so actually you can't start plumbing environmental variables into there. You need to do some setting on the config file so you can get your env variable in there. So it's just worth considering that sort of inside and outside view. Of course, you can simplify your life a great deal with a compositing tool such as Fig, and I just did a great job of demoing that, and to kind of take what I had with a whole bunch of individual Docker run and link commands, and then put that into a Fig YAML, you've got a much simpler structure in terms of expressing that as metadata and in terms of your sort of runtime stuff on the command line. But once again, I still need the complementary piece inside. My containers need to be able to pass those environment variables for the linking. So Jerome touched upon the existence of other networking nodes in his talk this morning. So let's have a quick look at what they are and what they do. Net equals host. So net equals host is all about saying, this container, don't give it a container-specific networking configuration. Let this container share the network config of the host. So if I spin up a container with ---- net equals host, and I go into that container and I do IP link and IP address commands, I'm going to see the ETH0 and any other Ethernet interfaces that I've got configured on the host. And I'm also going to see the Docker bridge. So I'm actually living at the host end of the Docker bridge now rather than at the container end of the Docker bridge. So that can be kind of handy when you want to take a container and just make it part of the host's network. And you might want to do that if you just want to directly expose stuff onto the host. You can also say net container and then link to another container's identity. And what I'm basically doing here is I'm welding another container onto the side of an existing Ethernet pair that's been created in the network namespace. So if I'm doing it against container 2 here, then my new container is sat on the other side of vETH 9C5D, and it's seeing an ETH0, but it's the same ETH0 that belongs to container 2. It's got the same IP address associated with it as belonged to container 2. Then finally, you've got net equals none. So you're creating a container and you're kind of just stranding it from the network. And that might seem like it's going to be pretty useless. But actually, when you get into some of the other advanced tools, net equals none can be a really good starting point for using the other advanced tools, because you're taking a container, you're spinning it up, and you're kind of saying, all right, I'll deal with networking later. And then you can come along and start plugging in those other networking aspects, rather than spinning up a container with the defaults, having it attached to its regular 172 network, and then starting to bung other networking things onto it. So connecting containers between machines. We've had a few sort of pointers towards and a few questions about okay, how do I escape single host linking? What if I've got some containers on machine A, some containers on machine B? How am I going to do that? The first sort of really good implementation of this that I tripped across was Marek Goldman. And if you're not already kind of following his blog and stuff, he's done some great things with Docker. I just saw an article that he published in the last couple of days where he was looking at constraints and how you can monitor what's going on in the container environment from the C groups. So that's well worth a read. This is from months ago. So Marek did this with Open vSwitch, and he took 2 hosts running Open vSwitch. Open vSwitch has had mainstream kernel support now since forever, at least in Docker time. Certainly if you've got a kernel that's new enough to run Docker, it will have enough Open vSwitch support in there for you. So at a physical level, those hosts or even VMs are connected together by the usual plumbing across a local area network. But Open vSwitch is allowing us to create an overlay network using GRE tunnels between one machine and another. And what this means is I can now stretch my Docker network across multiple hosts. That gives you an IP address management issue because you've not got the Docker process taking care of assigning IP addresses on each individual host, because it was never designed to do that. And it might change to do that later, but it hasn't done that yet. So you need to take care of the IP addressing, and you might want to do that with DNS mask or something like that. But that's a bit of an exercise for the implementer. So this sort of thing has been genericized a little. This was something I bunged into the latest Open Data Center Alliance usage models. So it's a sort of more generic visualization, at least, of container internetworking. And following up on what Marek had done, and at the behest of some people that wanted to see it just proven that it could work, I did an implementation along these lines with VXLAN. And if you go look at my blog, you can kind of see the adventure that became. I was initially very unsuccessful with that because it turned out the initial release of Ubuntu Trusty had a kernel in it where the VXLAN caused the kernel to panic every time you used it. So I'm guessing we're wandering into parts of kernel implementation here that aren't really well tested on the test matrices. It works now with 14.04.1 and the kernels that come along with that. Flocker has received quite a bit of attention already this morning in its ability to manage state across a number of hosts and the containers running on them. But one of the interesting things that Flocker also has is this network proxy that sits at the front end. And what that's letting you do is Flocker doesn't care which machine at the back end is running the services. It will direct you to them. And hence, you can connect to any of the machines within a Flocker cluster, and the proxy is going to take care of that. And I think this is sort of subscribing to what I would term the IP tables magic school of Docker networking, where you're not treating containers as sort of first-class citizens of the network. You're just putting a whole bunch of stuff in front of it that takes care of redirection. The other camp of Docker networking is to treat containers as first-class citizens of the network. And that's what happens with Weave. So Weave was released this Tuesday. It comes from the guys that did RabbitMQ. Alexis is at the back of the room, so if you're interested in Weave, go and talk to him. And it consists of a router component that joins together to form what is essentially a giant virtual switch across a number of hosts, and then the scripting to plumb containers into the Weave network so that you can connect them up across hosts. And then you can have on and off ramps so that you can connect into the Weave network in much the same way that you're exposing ports for individual services, but you can expose anything that's on the Weave network in that way. And you can have off ramps into sort of your state management or other services that might exist elsewhere in your network. So one of the interesting potential things here is that database could be running in your data center, and the services that you're exposing might be at the cloudy end. And as long as you've got weave routers joining up that network and able to communicate with each other over TCP and UDP on the port it exposes, you've got end-to-end connectivity. And within that Weave network, each of those containers, you're going to assign an IP address to. So you're back to the same problem that I referred to with Marek stuff of you're back in the business of IP address management. But I think if we look to the future of these things, then that will become a solved problem as it integrates into metadata services, whether you're binding early at design time and maybe using DevOps tools, or whether you're binding late orchestration and using Kubernetes or something like that. Should probably mention Rudder here as well. So the CoreOS guys are here. They've got a networking project called Rudder, and that's predominantly at the moment taking care of IP address allocations that are used by an overlay network originating from the host. Do you still want more? Okay, so Jerome was being very coy this morning, I think, when he mentioned pipework, because pipework is his project. So it's not just some random thing that is cool out there, but it's a great script that allows you to create bridges, attach container interfaces to those bridges, attach to host interfaces, and much, much more. So well worth checking out on GitHub. And Milos, where are you? So Milos has kind of taken what pipework does and packaged that into a Golang package so that you can programmatically do the same sort of things that pipework does, but through an API rather than through a bash script. There's also libchan. So libchan was launched at DockerCon, and it's described as a low-level component we can use as a communication layer across the board for the different aspects of communication within Docker. And I've kind of, that's my emphasis on what Solomon said. So libchan is providing Go language-like channels over the network, and it's a lightweight system to do that. What it actually does is yet to be revealed, I think. And so it's one of those watch this space things. But also, because it's going to be a set of libraries that are available for people to write applications, then you'll see applications integrating in with libchan. There are some gotchas that I should probably highlight to you. So this stuff here can behave a little bit like our old enemy, the network hub. And what I discovered to my own cost here is, if I set up some IP table forward and copy rules, and I say, when I see a packet from this container going out to this address, can I copy it into this other container? You can very easily create a loop on your IP tables there, because that packet gets copied, and IP table goes, oh, look, there's another one, and another one, this is quick, and another one. And then you set off the loop detection mechanism, and none of the packets go anywhere. So your service fails, and your monitoring fails. Great. It can also, by default, look a little bit like a home network. So the Ethernet interface on your host behaves a little bit like your DSL or cable connection to your ISP, and all of the rest of it is like being behind your router, and therefore difficult to expose to the rest of the outside world. Your host being a router can also cause you pain and grief. So if you look inside of the detail of pipework, for instance, it will tell you that you need to configure VirtualBox to use a particular kind of network adapter in order to play nicely, because some of the adapters don't support the correct promiscuous mode, da-di-da. And you can get into real trouble on just about any cloud, but I'll pick on EC2 here, because of source and destination checks that are enforced within their networks. And so you can set up all kinds of fancy pipework stuff inside of an EC2 instance, and none of it will work, because EC2 is doing magic in its network, which never anticipated you were going to try and do that. And what you're trying to do looks like evil to the cloud. And that's why we need to have overlays, because the cloud underlay has never been designed to support those sorts of things. Mileage varies with other clouds, but just about all of them have got an impossibly hard to find and difficult switch to flick, if it's there at all, in order to disable some of these things. And quite often it's called something like security. So it's kind of, you're then going in and flicking the bit to say, turn the security off, which never feels comfortable. The end, nearly. Docker is great for application network services, so SSL termination, proxying, reverse proxying, load balancing, content caching, and NIDs. That's why we put it into our product, and most of those things are using kind of great open source projects that are out there, like Nginx and HA Proxy and Varnish and Suricata. So we're at the end. There was my TLDR. I went through Docker 0 and the IP tables magic. Linking, we've touched on a few times already, and linking's easier if you've got compositing. And there are a bunch of great other advanced tools and options out there for you to play with if you're interested in Docker Network. Thank you very much for your attention.
Chris, when does a DevOps tool stop being a DevOps tool and start becoming an orchestration tool, or shouldn't that be allowed?
I don't know what that has to do with networking, but I'll have a crack at it anyway. This will be long-winded. My view on DevOps is that DevOps is not actually about tooling at all. It's an emergent thing that we identify when organizations have reached a certain stage of design maturity, and they've moved from design for purpose to design for manufacture, and they've achieved design for operations. And when you get to design for operations and then you implement your design for operations, this thing called DevOps is one of the artifacts of that. And so, these things that we call DevOps tools that we've used for configuration management, and these things that we're looking at now that do orchestration, they are just sets of tools that come into these practices. And I touched upon early binding and late binding when I did the talk, so let's kind of go back to that. If I look at a DevOps tool like a Chef or a Puppet, and I'm working with metadata there, then I'm effectively doing early binding of my metadata into my application. And that's fine. I mean, early binding occurs all over the place. If I'm dealing with the metadata within the framework of an orchestration tool, then I'm doing later binding than I would be doing with a configuration management tool. And so, we use late binding in programming because we don't anticipate the answer. We wait for it until later. And I think that ends up being the core distinction between those two things. Luke, you said you had a question, but...
Hello? Hi there. Yes. One of the things that troubles me about Docker is that there's a great dependency on a very limited network infrastructure. You've just got basically a breached interface, lots of containers. And I always think about, how am I going to implement any redundancy? How am I going to get containers running on other parts of an infrastructure when you've just got that very weak link? Do we see that changing? Or is it going to be completely dependent on third-party tools like your own?
I think there's a number of things come into play here. So part of my adventure that led me to the comments about EC2 was somebody came along in the EC2 forums and basically said, I'm running a whole bunch of services inside of Docker containers, and I want to make them available to my enterprise on the other side of a VPN connection. And what he was trying to do was basically have each of the containers sat on their own IP that would be addressable from the data center end, kind of reaching out into Amazon. And we kicked around a few different ways of solving that problem, and I don't think it is a solved problem yet exactly, because one of the things we tried there was to say, okay, you can put multiple NICs onto an Amazon machine, so I can have an ETH0, an ETH1, an ETH2, an ETH3, and then why don't I create a separate bridge from each of those NICs into the containers, and then I can have container 1 on ETH1, container 2 on ETH2, container 3 on ETH3, and it's kind of, oh wow, now I've got something that's starting to look like a resilient infrastructure. And you could definitely do that within your own data center, but because those virtual Ethernet interfaces that you get at Amazon aren't real, they have all kinds of constraints associated with them that I sort of touched upon, that you basically can't do what amounts to the masquerading between the container end of the link and the Ethernet end of the link, because Amazon's network won't let you do that. And there aren't even bits that you can tickle to make that work. So I think the answer is, if you want to build a resilient hardware infrastructure and then start associating aspects of your container infrastructure with that, the plumbing exists. And so you could do that with net equals none, and then creating your own bridges, marrying those bridges to the redundant infrastructure, and using pipework to assign the container ends of those. So yeah, it can be done, but good luck trying that in anybody else's infrastructure, because they might be doing something with their underlying network that's going to prevent that from working.
Okay, thanks. Just another question about IP6. So in your networking talk, nothing was mentioned, and like NAT was invented as a workaround for IP version 4, and now we see Docker having NAT all over the place. So our current approach is using IP6 and giving every container an IP6 address in a 64 subnet. Do we have any experience with that? Because at least you would get rid of this slide you showed with this home network and behind the router NAT stuff, which looks like DSL.
So I kind of share, I think, your belief that IPv6 will end up being the answer to some of these container networking problems. And I think if you get into that sort of type 2 mindset I described of containers being first-class citizens of the network, then you only really get to do that in a broader network address space that you get from IPv6. So what we're seeing at the moment are a lot of what my CEO calls cat-in-the-hat situations, and we're ending up with this kind of Russian doll of networking effect, where we've got a container network inside of a VM network, inside of a host network, inside of a wide area network connected to the internet. And quite often, the address spaces, because of the limitations of IPv4, are being folded and folded and folded. I think I would like to hope that the explosion of containers will be one of the things that finally drives us to IPv6 adoption. And I'm somewhat dismayed, on the other hand, that we're still kind of just hacking away at IPv4 and taking all of the kludges that have worked in the past, because they still sort of work now. So, for instance, I've raised the question with the Weave guys about whether they're going to support IPv6, and they don't yet, because it was only released on Tuesday. But you can see the GitHub issue there, and you can watch whether something happens with that, or you could even contribute and make it happen yourself. So, yeah, IPv6 and containers, I think, should be going together, but it'll take a little bit of time.
Okay, thanks.
Hey, so you talked about the sort of two camps of container networking. I guess you could broadly characterize the first one as having a container have a first-class address on the network, and the second one is identifying a container more by some sort of protocol host and address pair or a socket. Do you think those are compatible or incompatible?
I don't think they're kind of an oil-water incompatible mix. And I think it then becomes a question of, why do you care about networking, and what are the ends that you're trying to satisfy? So I think quite often we care about networking in sort of that native networking camp, because we're using things that have been designed for a world of hosts. And things that have been designed for a world of hosts expect to work with things like IP addresses. So to sort of stay comfortable within that thought paradigm, then you need to make the containers first-class citizens, and they have their own addresses, and you can point things at them that way. I think the world of it doesn't matter as long as you can reach it, and the reaching it is achieved through a whole bunch of IP tables forwarding magic, is a world where everything is just a service. And this, when you're consuming a service, you should not care about the implementation of that service, and hence you shouldn't actually have to care about the networking characteristics of the implementation of that service. So I think that stuff comes about very much more where we're thinking about services-oriented architectures. We're thinking perhaps about using a platform as a service to deliver services on services-oriented architectures, and perhaps we're using some of the orchestration tools, Kubernetes, etc., in order to implement scale and provide the automated mapping. So I think the second camp, if we can call it that, is one that scales more elegantly. But then let's not forget, we've built global spanning networks with the networks camp, and we know that scales as well. So I think the two aren't incompatible, and that they just actually represent origin mindsets of how we deal with network identity. Actually, Tim asked me a question which I was supposed to address in the presentation, and I forgot to. So he said, can you talk about how you would run things like statsd daemons? And the problem that you have there is port mapping. And where we're thinking about ports and port mapping, the whole cat in the hat thing starts to come into play. So I could run a statsd daemon on every single one of my containers and have it listening on its usual port. And that would be fine as long as I was trying to do things to those containers from the host. And of course, that's probably not what you actually want to do. And then you've got the problem of the host can only give you one of those ports to map before you're then mapping onto unusual port numbers, and now you're in trouble. Now you could put more Ethernet interfaces or logical interfaces into the host and start having more addresses that way. I think where we're probably headed here is we will do class-specific or purpose-specific overlay networks. So if you kind of go back to the practices we saw within large financial services and big enterprises, they would have a primary network, a market data network, and management and monitoring network, and all of this was built at enormous cost, and that's why nobody else did it. And now we could potentially have an overlay network for management, an overlay network for monitoring, and an overlay network for this and that and the other. And we can do that at essentially no marginal cost. So I think in the long run, the answer to stuff like the statsd issue becomes, just run a statsd network and just have the network purely there for statsd. So right now it's fiddly, but take a look at something like Weave, and that might suggest where the answer is going to be. Have we still got time for any more?
Yes, just wanted to know, are there any more questions for John Daniels?